right, ninjas, let's get to work on another one. This one's called reverse list order, another one in the 8 Caillou series. So in this kata, you will create a function that takes in a list and returns a list with the reverse order. Very simple in its instructions, right? Consider 1, 2, 3, 4 goes to 4, 3, 2, 1. And similarly for the second example. Really clear what you're supposed to do. So go ahead and do this. You'll notice in the coding section, they have a bit where they don't want you to mutate the original list represented here. I did go ahead and run it just to see if they're, they'll pass the test for you even if you do modify this list, but it would be good if you could do it the other way too. And so before I offer my solution, to pause, but also I want to talk about this idea of how variables are passed in methods. It's one of those things where it's not explicitly clear what's happening, and you have to sort of know about the language to understand what you're dealing with. And so if you want, you can fast forward to the end of this video if you just want to see some solutions, but this is a really important concept, and I'd encourage you, especially at the beginner level, to just consider it. You don't have to fully understand it, but at least it should be on your radar after this video. So the concept is that there are sort of two ways. Imagine someone using our reverse list method, and when they call it and enter a list in, what happens? Are they giving us the exact list, or the other option that a computer could do to handle that situation is to make a copy of the list they reference and pass that in instead. And you can imagine the difference is if they're pointing at the exact same list, if you do any changes in your method, you're actually changing their copy of the data. And in some places this is desirable. Other times you may not want this at all. You may want to protect your data, and you don't want people who are doing calculations on it possibly rearranging your data and getting something wrong. So there's a great article that the docs offer that I would like you to read. Passing parameters. In C# arguments can be passed to parameters either by value or by reference, right? Value would be sort of like a copy. Reference is it's pointing right at the specific data, and any changes will persist. Passing by reference enables function members, methods, properties, indexers, operators, and constructors to change the value of parameters and have that change persist in the calling environment. That's what we talked about. That calling environment is the outer scope that your method is called from. Do you want the changes to persist there or not? To pass a parameter by reference with the intent of changing the value, use the ref or out keyword. So maybe you've encountered this in other code and you've been confused by it, like, what is this ref? I've always just passed arguments. What's this ref thing all about? So in this case, they're trying to force arg, which is an integer, to be dealt with by reference. Spoiler alert, int by default will be a value type. There's two types, value type and reference type. Int's going to be value, so they sort of override that behavior. And you can see it in the code example, right? They set it to 4 here. They have a simple method that just squares it. And then they write the same value again, right? And this is a great way to highlight. Notice the output's still 4. You squared it. You might be expecting that to read 16, but it still reads 4. And that's because the integer is a value type. When you pass it as an argument, it's passing the value 4. It's not passing the memory location where you made this variable, right? Somewhere in your computer, this integer is being stored in some register, right? Ones and zeros, a byte, registers. And so when you pass it, you could point right at the memory corresponding to this, in which case, you're absolutely going to change the value. Or you could just take that representation of 4 that's in there and pass that value instead. And that's what they do for integers. But notice this now. You can use this ref keyword to override that default behavior. Now you pass 4, but by reference, pointing at the exact memory location. And when you do that, now you can scroll down if you want to see the square ref. I mean, it's just got the ref keyword, right? Same concept, multiply by itself. But now you get that output 16 that you may have been expecting the first time. So cool. That's nice. That good to know, right? How this stuff is working. And then notice there's this in, out, and ref. I don't want to get too far ahead here, but by all means, read more about these other types, other ways of passing parameters. And you can hit me up with questions too if there are any. But I wanted to touch on that concept. So back to the problem now. Well, yeah, list is of type int, but our type is a list, right? So we saw integers or value types. Well, what's list? I don't know. Let's ask Google, right? What do they say? List is a reference type since it's a class. So that seems to be how the language handles the classes. And same when you make your custom types, right? They're going to be classes. So that suggests that if we modify the list here, it's going to change. So let's find out exactly what's going on, right? I'm going to make a helper method that just simply prints a list, right? And we're going to basically use it to print the list before we work on it and after we work on it. And then we can see if what's happening is what we expect to happen. I'll call it print. It'll take a list. And then we know we have, we'll use a for each loop. Int n, n's a common variable name for integers. For each one of these, right, we want a console, spelling matters, write. I'm not going to use write line. I'm just going to print the whole list on one line just to help us read it. We'll use that string interpolation, and I'll say, and I'll put a space between each number, right? Notice I used write, so it won't create a new line. And then at the very end, when I'm all done, I'll say console write line. And I don't need any content. I just want to make a new line, so I left it as an empty string. But this will help us, right? So we can start. I should show you first that hopefully your alarm went off thinking reverse. That's probably a common thing people would want to do. I bet list has something built in, and sure enough, you would have been right if you had said that. You may have been looking through your methods for list to see what you have at your disposal, and you would have found this reverse. So let's do it. You can do it that way. You can say list reverse. List reverse returns void. It doesn't return a new collection. So you do that, and then you hit return list. And if you run this, it should pass. But it didn't quite. Oh wait, what did I do? Top level statements. 14.1. Oh, sure. We didn't have a return type, right? That's a bogus contract. That they called us out on it, right? Remember, you have to say you get your input and you have to specify your output, right? Otherwise, you gotta play by the rules, right? No deal, buddy. So yeah, good catch there. Void. I don't need to return anything. I'm just printing to the console. Let's try again. And I already know they're going to yell at me because I'm using console. I didn't define console. So let's bring in the system namespace. See what happens here. Use preview. Modifier private. Oh, I know that. Oops. So I just kind of floated this print statement outside. I'm going to put it in my class. Right. These access modifier keywords make sense within the context of a class. That's where we can sort of encapsulate behaviors and data. So let me see if that fixed the problem. Good. Okay, so no problems there. We solved the problem, right? It works. List nicely provides that feature, but we're going to find out we actually mutated the original list. So what we'll want to do is something like, we'll say print, just to start, right? Before we go meddling with anything, we're just going to print and see what the contents of the list are. And then I'm going to make this extra reverse method just so we have the outer scope here in the original reverse list method. So I'll make private static list of int. I'm just going to make my own version of it, my reverse list. It's going to be the same kind of deal. Okay. So now we can do whatever we want to do. In this case, you know, we just said we use let's do that because that's the solution we use. List reverse and then return list, right? Because the reverse operates on the list itself if you look at the documentation for list. Okay, and then after we do it, we printed it to start, then we call my reverse list. We know it does the job, but the question is, what happens if I call print again? And then since this returns a list, we'll call it reversed. And so we could see, and maybe we'll just add a print for the reverse too. See. Okay, so when we run this now, let's check out what's going on. Okay, it's still good. We know it works, but we didn't really comply. Let's make sure we're complying with their added directions. Now look what happened here. So print list, we got the 1, 2, 3, 4 that we were expecting, right? You can see from that first test case. And then we printed the list, this exact same input list after calling our function, and it's 4, 3, 2, 1, and they didn't want that. And of course, the second call to print reversed is the same thing. We just returned the original list in reversed form. So we're overachievers. We definitely want to do this without mutating the original list. Now we can rework this, right? We could look at this as a way, one option would be to make a copy of the original list, right? Where it contains all the same data. We're just making a duplicate. It's stored somewhere else in memory. And then we just reverse that list and we're not touching the original. So, I mean, you could do something like that. Now, you notice the list constructor. If you want to go back and look at that list constructor, you can provide it a list as sort of a source and tell it to basically copy an existing list, but you kind of have your own copy of it that you can manipulate and work on. So if I do it this way and I say return reversed, I would expect that the original list would no longer be modified. Let's see, what did I fail on? Oh, sure. We didn't actually reverse it, right? We forgot to call the reverse. So reversed equals, actually, and then let's call this list copy. Just try to make this clear. It's not reversed at the time we construct it, right? It's just at this, after this first line, it's just a duplicate. It has the same stuff. And then I'll say list copy reverse. That's what we did before. And then return list copy. So yeah, I forgot to actually run the reverse. Sorry about that. Okay, test failed, expected actual pull. List with 4. 4 plus 1, what did I do? Oh yeah, so then in our calling function now we should be returning reversed. That's good that it failed, right? Because previously we were returning list, which is just a copy of the original, which is what we were trying to achieve. So before I run it again, yeah, notice that the before working on it, we got the 1, 2, 3, 4. After working on it, we got the 1, 2, 3, 4 for the input list. And then when we printed reversed, that was the form we wanted. So let's try this. This should look better. Good. Yeah, so that's one option, right? And that, you know, you don't have to be a computer science guy to think, you know, imagine I gave you some structure, right? You could, but I said I don't want it modified. And you might, like, imagine I gave you a drawing or something and I wanted you to do something cool with it, but I didn't want you to touch my drawing, the copy that I was giving you as a reference, right? And you could put another piece of paper over and trace it, right? So you started exactly with my, you know, pencil sketch or pen sketch. And then once you transfer it over onto your paper, you can do all the cool, whatever job I hired you for, right? Maybe I wanted you to color it, but I wasn't sure if I would like your color scheme. So I wanted you to do it on a copy, and then you go and color it. And maybe I love it, maybe I hate it and say, no, try it again with these colors. You know, that's kind of the idea here. You make a copy of it, do whatever you want to it. If you mess up, whatever, we can try it again. So that was this strategy. I'll go over one more quick solution where we're not using the built-in reverse method of list. And then this is more like we've been doing, where you kind of roll your own solution using basic building blocks. So I will put aside the printing stuff for a while. We won't need that. If you didn't know the multi-line comments, that's very nice. Instead of the double /, you got the single slash and then an asterisk, and then it ends with asterisk slash. Nice quick way. So anyway, how do you do this otherwise? Well, it was kind of like that string problem with the characters, duplicate the characters we did in the last video, right? If we create our own list separate from the original list, we can sort of build this thing in place as we process data. So let's start with that list of int. This is just our list. We can call it reversed. And then make sure you initialize the list. That's a common mistake. You don't want to forget to actually construct a list. Now we're going to go over the input. We'll use our nice for each loop there, int n in list. That reads very nicely. And now, remember with the characters, we kind of went from left to right like we read in the West there. It's a little different here though, because we want reverse order. So instead of appending to the end, I'm going to take my list collection. I'm going to keep inserting at the beginning. And you can imagine if I'm reading the numbers from left to right, and I'm always taking the next number and putting it in front instead of the back, you can hopefully visualize how that's reversing the original order. So if you didn't know, you could go back to list, and it has this insert method that you can use for that. It's handy because you don't have to insert at the beginning. You could insert somewhere else in your list too, but we're going to use an index of 0 because we always want to go at the beginning. So I would say reversed, insert, remember the index first, and then the content that you want, which has to match, right? I'm using integers. So I'm taking that integer, whatever one I'm on, it's going to start at the beginning. Each time through the loop, right? It's going to keep looping, grabbing the next number. And every time I'm inserting it at the front, which is going to push the numbers that were already loaded sort of to the right. And then once that's done, I can simply return reversed. Okay, assuming I didn't do anything wrong here, we'll go ahead and run this one. Yeah, looks good. I'm going to clean up and remove some of this print stuff that we did just to kind of show the idea of pass by reference, pass by value. It's a very important concept. It's going to factor in a lot. It's unfortunate too that you don't really know about this stuff until your code just doesn't work and You look at it 100 times and you can't figure out why it's not behaving like you expect it to, and then you find out sort of these things are implicitly happening under the hood that you just didn't think of. I almost wish there was a starter manual that had some of these gotchas and things you may not be thinking about. But anyway, I'll submit it like this. Sure, why not? We'll run the larger attempt, hopefully no problems. Looks good. We'll go ahead and submit and check out what other people are doing. So there you go, enumerable reverse list. And then they're converting it back to a list to match the type. So list as enumerable, reverse the list, same kind of idea. This is nice, it shows you that the standard way you use for loops is you always start at index equals 0 and then increment. And this shows you, hey, you can read from the back too. That's cool. Another common thing people think is that you have to plus or minus your index. You could actually go up by 2 every time or multiply it by 5 every time, whatever fits your scenario. Reversed list. So yeah, feel free to keep checking through those. Don't feel bad if you don't understand the whole by value, by reference thing. I hope you understand the high level concept. It's going to come up again. It's definitely worth your time reading about. But in computer science, just know that you're not always going to understand everything at the first pass, and you have to get comfortable with that. That's something that was very difficult for me. I like to know everything, and you have to trust the process and that you learn a little bit more each time. So you're going to read the same article again in a week, or some other, sometimes just get someone else's perspective on it. They're going to say words in a different way, but you're a different person because you had, 10% understanding, then you have 20%. And over time, it becomes clear. So don't beat yourself up if you don't fully understand. And that's what the comment section are for in the videos. Drop questions if you have them. Otherwise, we'll call that one a wrap, and I'll see you in the next one. Thanks for watching.